Hello, and welcome to the stream. Let's see. Everything should be set up correctly. I think so, at least. So, during the last episode, we started building out a shadow map. I also told about the overall plan for this streaming series. I'm gonna finish up some different stuff here, and then I'm gonna go start on a more interesting project. Yeah, I'm hoping to stream over the next couple of days. Um, um, and like, kind of like, get started on that new project. Yeah, so I've got some different ideas I want to work on. Uh, we should probably clean up the state machine behavior and the last parts of the actual chess game structure. And we want to add simple shadow mapping. And then I was considering um, doing it on the stream in this part of the series, but actually I think I'll do it as a kind of like start on the other stream, but um, for the new project and probably the next couple of streams we want to implement a more dynamic lighting solution. We can port some of the FPS code. We want to improve on our debug information pipelines. I want to probably. I don't think we're utilizing the GPU very much right now. I think um, we're really waiting on the actual GPU, as you can see from our debug information here. The weight GPU is a fairly few microseconds. You can see we use so about. Let's just screenshot this so it gets easier to read. So the waiting for the GPU is far lower than the actual draw itself, which is most of our actual application tech. That's pretty normal, right? But this means that we're using a lot of CPU time on actually registering the whole draw command stuff. We're definitely doing a lot of FPS, so we have plenty of CPU time to work with, and my CPU is of course slowed down from both running Spotify, OBS, Discord, Visual Studio, a browser, and so forth. So um, without all these steps, or rather applications, we're doing way better. But anyway, I would want to defer some of this stuff. For instance, the rendering of these cubes, which represent the bounding volumes to the GPU. I would also like a cube um, bounding volume pipeline, maybe, yeah, and a sphere bounding volume. It's just, yeah. So I would like that, since right now our renderer basically updates the whole draw debug here. So we kind of like manipulate the whole thing on the CPU side. Uh, we update the debug data. We update the vertices, for instance, here. We um, yeah, uh, we set the colors, we do stuff like that. But in general, I would want for this workflow to be something like um, something like um, for instance, this step here, uh, we should probably be able to pass in something like a AABB or uh, a bounding sphere with their parameters into the GPU, and then create a mesh shader, or not mesh shader, geometry shader that simply builds the whole thing for us. We have the code basically um, right here. Um, um, and we would just need to create a geometry shader that would build the whole set of vertices and draw them. Um, yeah. Yeah, so that's it. It should probably still be a line based shader, but yeah. Anyway, I'm getting off topic. The whole point is that I don't like this whole system where we um, have to kind of like uh, switch update the whole thing on the CPU side. Um, Yeah. It would also allow us to use the transforms. Yeah, but anyway, I want to try out using a geometry shader for this. Um, so that we can simply tell our system to create a new bounding volume. And the reason why I want to do that is because I would want to be able to draw different bounding volumes or different debug visuals in terms of representing different stuff. Also, it could easily be coupled with a decall of sorts, for instance, for an icon or whatever. So you could couple like bounding volumes and an icon for lights and so forth. But anyway, that's at least what I want to do. So last episode we actually started rendering our shadow map information. As you can see, shadow map. Let's see, what did we call it? Did we actually name it? I can't remember. Shadow map depth buffer at least. Let's see. Let's see. Can I? Yeah. So we have our shadow map here. And if we manipulate it, you can see that it has a sense of depth in terms of the models themselves. And next we need to implement, I think at least, we build out our shadow map here, and that works fine. For now, we do it for all polygons. So we build our map. Then we should, of course, bind it to our polygon shader itself, since we, during the pixel shading, need to use it. And we don't have anything actually bound for yeah, I'm just thinking about actually binding the thing here. Maybe we want a Maybe we should create a method. Yeah. Where we only bind the pipeline states. And the reason is I only want to do it once. Let's see. Should be fine since we don't change the root signature. Yeah. And we don't have any errors as far as I know. Nope. Yeah, so that works. And we don't need to do this because it doesn't matter, I think. Oh yeah, okay. It actually does have some difference. Doesn't match pipeline state object, yeah. Okay. Since we're using so much of the same stuff, we don't want to change the root signature. We might as well bind it and not change it between these two pipelines. Okay, so we have a and we should order in terms of how often these things change. So we have a descriptor table. Instead of a table, we have uh, a series of object matrices. Let me think. So, do we just want to bind an SRV? Or what do we want to do? Well, we could use yeah, maybe we should just use a series of SRVs instead of a table. We could always move it into a table and just live with the extra degree of indirection, but um, yeah. Um, yeah, we could use. It doesn't matter too much right now, I think. Um, okay, let's create a. Hmm. It doesn't really change, or rather, the actual pointer doesn't change. It will keep on pointing to the same. It will keep on pointing to the same thing, so it shouldn't really change. Yeah, I think this should actually be the first one, but come to think of it, but uh, do we want to separate? Uh, okay, whatever. Um, anyway, okay. Let's create a parameter which has the SRV type. We're just gonna, right now we have the space in the root signature for it. Descriptor. Let's see, shader visibility. Uh, primarily for the pixel shader here. Uh, let's see, shader register 0. And the register space will also be 0. And the flags will be none. Okay. So we have created a way to bind our texture. what do you call it? Our shadow map. Graphics, root, shader resource view, number 3. And we have our first slot of the the first CPU handle of our really nicely named thingy here. Let's see. GPU descriptor handle. Okay. Oh, wait a minute. Virtual address, of course. But let's see. Okay. So we're not really using the whole resource view here, although we have it in a descriptor heap. Let's see, we can access it from the actual thing here. Pointer, I think. Right? No. We have a problem. Oh, wait a minute. That's not the problem then. I needed to update this. Okay, so it basically wants the resource itself. Okay. Okay. For non-buffer resources. Oh, wait a minute. What? No. Let's see. So it's a bit more problematic to set it this way. Let's see. Textures are not supported. Oh. Oh, okay. I can't bind a texture this way. Okay, so we need to use a table. Anyway, you live and you learn. Descriptor table, number of descriptor ranges. Okay, and we want to create a let's create a range more. One more range type. Okay, let's see. Materials table. Just so it gets easier to read. Texture tables. One. Let's just do 0 here. Register space 0. And let's set the offset as well. And let's set the parameter here. Range. There we go. Should be better then. This should compile then. And run. Okay. Let's get the GPU handle for the first one. And then let's see, descriptor table. And we need to transition the resource, I guess. Hmm. Uh, Okay. Let's see. Okay, maybe we. Let's see. Let's try to change the flag to volatile, and there we go. So we have to tell the whole system that we might be changing our data information during the actual execution step. Uh, uh, let's see what. Yeah, so we have a dependency here. Hello. Ah, cool. Yeah, I'm doing last steps to finish this project up. I'm just implementing shadow mapping. I guess that's a 3D feature. Okay, so we bind our that's just the way it is. I'm only streaming just to provide something that other people can use for reference or learning. I have no ambition of creating a big channel or becoming an influencer. I have a lot of work outside of this whole thing. What are you? So you're building a chess game or? Okay, so we have. Let's create a texture 2D. Global shadow map data. Register T0 space. Nah, let's not specify this. Let's see our past data here. Okay, so we need to be able to create the inverse of our shadow map, or rather the light view projection matrix. So let's see. Yeah, so we would want a, let's see, position in, oh, we already do it or what? No, ls is a bad name, right? ls is a bad name because it's not light space, it's, oh, wait a minute. Oh, we are actually editing the wrong shader here. So this one, yeah. Position in light space, position 1 here. And our past data here should have a float. Light, shadow map. Nah, not shadow map. Light. And right now we don't upload it, so, and it's hard coded. as well. Let's see. This is the resource creation. We don't need to create resource. Yeah, we don't need that as well. We need to upload draw data. Maybe we actually do it right here at the bottom. Right, yeah, we... Okay, so we could create a small buffer. We could create something like maybe we want some kind of like, not a linear buffer, but some kind of wrapper for the pass data. I mean, right now we kind of like upload this information here. After the pass data itself. It would probably work, since we kind of like hard code it right now. So basically when our shader is built like this, it would know, let's see. But yeah, this is not correct. Oh, wait a minute. Hmm. Yeah, we actually... Okay, there's actually no reason to uh, do it like this. Okay, so let's just change it. Pass data, light stuff. Padding. And let's do a XM float 4x4 aligned. Maybe we just want actually like this. Yeah, I'm not sure how it would change over different architectures, but so view projection lights. Yeah. We could also do delta time or whatever here. Could be delta time. So in here we will do a float delta time. It float 4x4 view projection light, and we will update our vertex shader here to hold the same path data. Let's see. Yeah, so we good. And we need to, inside our shadow map here, we need to use the light thingy. Okay, so whenever we create this, we will simply create a path data struct, temp struct, and set our temp data to our, let's see, XM store float 4x4, temp data. And let's do this. This is let's just copy the temp data. Let's do a size of pass data here. Okay. We just make sure that we don't override it. Okay. So this should run. Let's see. Okay, we have a bug somewhere. Okay. Yeah, because we changed which resource are we talking about? Uh, okay. Yeah. So we need to, of course, add this field here to the pixel shader. Okay. Let's see that our shadow map actually gets calculated correctly. Huh? Oh, we have a problem in terms of the. Oh, we haven't updated the shaders because we haven't changed recompiled here. Right. Okay. There we go. Okay, resource inspector, depth buffer, view contents, and we're back. Nothing changed. Yeah, so now we upload the view projection matrix to our shader, and we don't override it during the upload step. So now we can access it. And let's do the output position light space equals small pass data view projection for the light with the position. Yeah. And inside our pixel shader, we now know the position in light space, and we have our shadow map bound. Great stuff. Next step is actually starting sampling the shadow map. Okay. Let's do a float, calculate shadow factor. And let's pass in a light space position here. We need to transform into texture coordinates. For that, we use a hard-coded matrix. No, 2 UV chords. Can we do a const expression here? Return 0.1. Input, the light space position. And this is the matrix. Let's see. We could also do something like this, right? Let's see. So that's the one that needs to be set here, and then the should be all right. Let's see. Let's just try to compile these shaders here. Yeah, no problem. Okay. And right, let's see, float UV space. UV coordinates. Let's say light position, yeah. And since we're not using uploaded matrices, but hard-coded matrices, we can actually um, okay, so yeah, since our matrices are uploaded from the CPU to the GPU, their their ordering in terms of memory gets mixed. That's or swapped. Therefore, um, um, we need to position rather do it in the different order during the vertex shader step. Here we have the matrix first and then the uh, position vector, but here, since we're using a matrix that is actually laid out in memory on the GPU correctly, we can actually do the multiplication in the correct order. Okay. Okay, let's width and height for our shadow map here. G shadow map. Didn't we call it now? Shadow map. Get dimensions. Width and height. Yeah. And let's see delta coordinates. Since we are mapping to the range of 0 to 1, and of course we need to cast it to a float here. And then we need to create a series of kernels, float2. And we will start by creating and this also needs to be minus. And then of course the middle position and then the -1 here. And then the +1 and the -1. Okay. Let's 0 here. 2, of course, float2, float2. 0, 0. And the X here, the Y here. Let's see. Oh, I missed the comma. Let's see, and then the positive on the Y here. And the corner is done. Okay. Okay, let's see. So the negative corner, the positive corner, the middle, but with the negative y, and the middle with the positive y. Then the positive x, middle, top, bottom. Yeah, should be fine. Okay. Then we need to create a what is wrong with this? Oh, I need the variable. Light accumulation is equal to 0, and we will right now this will be 0. Right now this will be okay. And lastly, we need a sampler to sample our shadow map, and we will use the built-in compare on level 0, the map 0. But first we will create this sampler. Right now we do not have any samplers in our root signature. Samplers. Maybe we want to create these samplers up here. Let's do static sampler descriptions. Sampler descriptions. Let's start out with 1. Yeah, and these should be generalized. static samplers. So we will create a shadow map based sampler. Shadow map sampler. Let's see. Okay. Let's see. Just a second. We will create a sampler that is a point sampler. Okay, so sampler, not sampler, sampler. Description with a filter. A linear sampler, not MIP, is it? Let's see. Can I find somewhere else? Yeah, compare the. Yeah, that sounds pretty much what we want to do. If you remember, the description of the actual sampler here was samples the texture on a MIP map level 0. The shadow map only has a MIP map level of 0. If we were doing cascading shadow maps, we might have more quote-unquote MIP maps, but probably just different textures to sample from. Anyway, we compare a single component against the comparison value. We want to grab the depth value of the or rather, since we have a texture, we specify the shadow map texture coordinate space and use our kernel to specify which adjustment we should use. Right now we're doing all of the kernel computations and dividing by the size of the kernel. So we want to know which part of the texture we want to sample, and we want to compare to the sensor value. Yeah. So we will do bordered sampling here. Whoops. We can just copy this actually, but no, I'm almost done. There we go. Minimum level of detail is 0. Max level of detail is just the maximum level here. We don't have any level of detail bias. Max anstrophic filtering 16. It's not a float. Comparison function is less equal. We want to compare if the value is less than or equal. And we will simply shader space. And we will shader visibility. All. Okay. And here we want to add our shader. Right now we might be, yeah, immediately the color of the whole thing changed because we did this. If we did something like this, we'd be back to normal. Let's just recompile. Yeah, so that's the reason why the color changed. Okay, let's bind the shader as well. Let's see. Sampler comparison state. Shadow map. Sampler state. Sampler 0. Okay. And let's make sure we recompile and copy our shaders over. Okay. Shadow map sampler state. Did I call it that? I should have, right? No. No, not data, of course. And then we want to and we should have sampling of our shadow map now. And as you can see, we're actually casting shadows. They aren't pretty, but we're actually casting shadows. And if we move the object, the shadows get updated. Okay, one thing I would want to change is the shadow map dimensions. I think we should create a 600 by 600 shadow map instead. It does help. it's kind of blocky, right? But I'm suspecting that the calculation of the scene radius here affects that as well. Yeah. We could also scale it up to double size. Yeah, we get much sharper shadows this way. Yeah. Okay, great stuff. Okay. And this is hard coded, so it's what I want to uh, make more robust in the next project. Mm. Let's play around with these settings here. Maybe increase the depth bias here. Yeah, it even casts a shadow on itself. That's pretty cool. Yeah. Yeah, I'm not sure the normals on these objects are actually correct. But once we get the whole debug information stuff updated, um, things should get better. I mean, does it make sense that, yeah, the light shines down here, it lights up this part, but keeps this somewhat in shade, I guess. I don't know. I don't know. Yeah, could probably play around with it. Yeah, yeah, we also need to fix that. Yeah, they're a bit kind of like floating and Peter Panning a bit. Yeah, yeah. But that's an overall engine improvement. Okay, so we have things kind of up and running in terms of the shadow map. I guess I would have to play around with different settings and yeah. We could add a kind of like system to only submit yeah, kind of like do some render grouping. We could do that. But I guess in order to wrap this up, um, since we have implemented the basic shadow mapping here, we should probably uh, probably uh, uh, hmm. Okay, so yeah, we could change that, but in order to wrap this up, just a second. Need to check some stuff. Anyway, we've updated our shaders here. So Let's see, game state. Let's see, messages. Click. Okay. And we process our input. Sorry about that, I had to sneeze. Maybe we just want none here, but so we have game state, start turn, turn, and turn. Okay, so we start our turn. And if the button 1 is pressed, so if we click, we do our stuff. Okay. And if we actually do this, we should send a message. If we actually make a move. We send a message. Messages. End turn. And did we actually have an index? Yeah, we did. And let's not do that. Let's just send a message. And we should move the unit, of course. Let's see. Okay, and we enter the Okay, maybe we want intern as well. Maybe we actually want it just for state tracking. Okay, let's leave it in. Okay, let's see. Okay, it automatically deselects now. Great stuff. But it doesn't actually move the object here. Let's see. Clicking on the actual pawn. Maybe we want. There we go. I think that is it. Yeah, the blue now. Whoops. The blue now moves over. Click the board tile. That works. The board tile stuff works. And the thingy works. Yeah, so both works. And we do have the correct change of state. So that's the actual cleanup of the state machine. Actually, this should also be set to 0. Okay. Let's just break here. We don't have to do it twice. Break. Break. Okay. And need to clean up that. Okay, so basically this leaves us with a chess board game that has currently pawns. It has a turn system. So as a wrap up on this project here, what would we want to do? Yeah, we would need, for this to be a complete chess game, if it's just a local player chess game, you would have to do check if game is over, calculate mate. Of course, we would want in this order add needed units and their attack and movement patterns. So we do something like this, implement specific movement calculations for um, um, the different units. Maybe we wanted to store it in a localized buffer, but we would want to add the units and their attack patterns. We would have to add the we could add the units and their movement patterns. We would need to add special rule sets, promotion, snipe pawn. I don't know what it's called, the chess rule, rooking, swapping tower with king. Is it the king? I think so. Um, um, and after that, you would have to calculate the possible moves slash checkmate to see if the game is over. You could then restrict calculations for possible moves for to only possible moves. Yeah, you would basically add some game logic uh, to decide whether the game is over, whether something is movable, whether a checkmate is preventable. Check as well, checkmate. And yeah, that's basically it. You would have a uh, um, chess game. Since basically the rest of the logic is implemented. Um, Let's see. Okay, I can't swap the turn right now. Okay. Mm. Uh, there we go. Okay, now we should be able to swap the turns, right? No? Okay. Then get a crash. Stuff. Stuff does trigger. Uh, uh, huh. Why do we have a crash right there? That's weird. Uh, uh, warning treated as error. Little spelling error. Okay. It happens twice? Why does it happen twice? Ah, okay. I have to. course, update the state. There we go. Okay, so we should be able to then swap the player turn and keep on moving. There we go. So that's the cleanup. We have our shell for our chess game, and yeah, the game state is basically a start of a turn and then an end turn where we clean up and change the game state. So it's a pretty simple state. Yeah. So if you wanted to expand, add more units, add a special rule set logic, and check if the game is over, and then you have a basic chess game. You can expand upon that, then add AI, which is usually recursive, or rather tree traversal stuff in terms of computing future possible moves and scoring these possibilities and selecting the best ones. Yeah, so basically that's it. All right, great stuff. I think that is it. For this chess series, yeah, we have shadows, even though they are not super nice. Yeah. So I'm gonna end the stream here. Yeah, we want a more robust lighting model here. Um, anyway, that's for the next project. So yeah, if you have any questions or any comments or whatever, feel free to leave them in the comment section down below. Yeah, I'll be starting the next project, which is going to be a more interesting project for me in terms of desire to actually work on it. If you remember when I started this small streaming series here, I was just trying to get back into programming after a long hiatus. So I guess we're starting to get there. And I'll do more introduction in terms of the coming project. Let's see. Doesn't it show my bookmarks anymore? Well, okay, Firefox. I don't understand Firefox. Let's see. Yeah. So I've named it Project Dr. Man's Rebirth. Um, and yeah, we will build different prototypes to see whatever will work. But yeah, I'll port parts of this engine so that I won't be starting over. I might change the API/core library a bit and the project setup, but yeah, I'll save this project here for something that I can return to in the future. But yeah, I'm probably going to stream the start of the project later today, so feel free to join in and see how I'm going to get started and hear more about what we're going to do. Yeah. All right. Thanks for tuning in and interacting in the chat. Feel free to join the Discord or support the channel. Yeah, I'm really excited to get this project going. So yeah, hopefully, it will be inspirational to others as well. All right, take care, everyone. Bye bye.